Hello, everybody. Welcome to the second part of Chapter 5. And similar to last week, we're going to start off with a case, and that's the application case. This one, we're talking about AMC. And I've talked to you guys before about Netflix and how Netflix is one of the pioneers in using analytics to decide how they program and how they provided content for their shows. Well, this case is about AMC in a very, very similar fashion. They were a few years behind in Netflix, but basically using the same type of technology and the same things by using analytics to help determine what it is that people want and how they could promote programming for that, and more importantly, how they can sell that to the advertisers, because that's where the networks make money. They make money a little bit on people's, they get a little bit of kickback from cable companies for subscriptions, but really where they're making their money, like all of them, is on the advertising. And so if they can sell this concept to an advertiser and show them what they do, that's where they're making their money. So read that. Hopefully you've read that piece. You were assigned that reading, and you have to. This is only here in the class or in the lecture that you'll know this. I want you to answer these 3 questions. So you can see it right here, and you can pause this and read them down. But I want you to answer these 3 questions and send that to me in an email. And I want it sent by the end of next week, so 1 week from today, which would be April 9th. That needs to be there by 6 p.m. So that's your thing. And if you paid attention and listened, you're ahead. And I'm going to send a note out to everyone to make sure they are paying attention to these lectures, because they are missing content and they're going to miss points as well. All right, then the first thing we're going to talk about, one of the big things you hear this term a lot today in analytics, is natural language processing. And the book does a nice job of going over the different categories. It talks about the question and answering piece. So questioning and answering is it's automatically answering a question posed by the natural language. And what it does is it produces the human language and then gives a human language response. So that there's 2 parts to it. It has to translate the question into human language and then respond in human language. And if we watched last week the video about Watson and the playing, and obviously on Jeopardy, you saw a lot of this. The next thing I talk about is automatic summarization. And what it does is it shortens the text that is spoken or an input to it, so that it only gets basically the subject, high subject. It gets where the things like is and the and it shortens that level. And then it creates that, the next thing is that the natural language generation, it converts it into a computer-based language so that it's more readable for the human. The next thing it goes down is talks about machine translation, which is the automatic translation of one of the human language to another. In this case, it can be literally from English to Spanish, Spanish to English, Spanish to German, whatever it might be that we're talking about. And then the form language reading, which is then it takes similar thing along with the machine translation, but it adds foreign language to correct pronunciations and accents. So for example, there are words that exist in Spanish that don't have a direct translation in English and vice versa. That's what the second part does, that the foreign language reading will make that, instead of saying a weird statement that doesn't make sense because of a direct translation, it makes those changes to get it in the right dialect and to make the same content meaning. This is fairly complex, and in my experience, this is still not 100% by any stretch of the imagination, and it's very different. In fact, I've seen people with strong dialects from the South that struggles with. After that, you have the writing that it takes that language and it's going to put that back out into the writing of it in foreign language. So if you ever seen these handheld assistants you get if you travel overseas, which no one's doing right now, you can speak in one language and it will translate to another language and it will write it down so you can see it. Then it's going to talk about speech recognition, which I think is self-explanatory. It takes the speech of a person and recognizes it and translates it. And then it also does the text-to-speech. It's also called speech synthesis. It's a program that automatically converts the normal language into human speech. And finally, the optical character recognition. It translates images, handwritten, typewritten, printed, wherever it might be, even math things you can be translated and to machine language. So those are the big categories in natural language processing. When we talk about the text language applications that are big out there and the ones that are important, you're going to have the marketing applications. It allows them to get information, and you'll see this a lot in CRMs or associated with CRM applications. Also, the one that's really taken over in the last few years is security applications and deception detection, where it's trying to figure things out. And one that right now is very big, as you can guess, is the medicine and biology, where it's trying to they're doing a ton of research, and now very topical with them doing research to find out other vaccines, other medicines that help similar type of viruses to COVID-19. They're doing a lot of that stuff right now, but it's been going on for years. And then finally, you'll have academic applications, which do a lot of this stream analysis portions of the text mining. When we talk about the application here, this one was labeled mining for lies. It talks about trying to detect deception detection. It's a very difficult problem, and if it's just in text or whatever, it's more difficult to do. So I'm not going to spend a lot of time on this, but the study, it analyzes the text-based testimonies of persons, and in this particular case, it was at military bases, and only based on the text that it created, it gave clues or cues to what was going on. And then you'll see here in this thing where it got the statement, it extracted and selected, it text processing the software generated more cues, it classified those models and trained them, and then based on that, it tried to determine whether or not what was being said was truthful or deceptive. And it's very interesting in how that's done. So with another example here would be how part of this is they look at the quantity, the complexity, the uncertainty, all into text and how linguistics is taken care of. If you haven't read that case, I very highly recommend you spend more time reading that case to understand how it is. Very, very interesting in itself. So the next thing that we're talking about is application 5.4. And for those of you still listening, this is the second piece that you'll have to send to me in the final piece from this presentation. The questions right here, which are, how did Innova use text analytics and text mining to improve quality and design of their products and ultimately improve customer satisfaction? That's 1. And 2, what were the challenges, the proposed solution, and the results they obtained? So those I also need to have emailed to me by next Thursday by 6 p.m., which is our next thing. So that's the next assignment. So with those of you listening, you'll be in good shape to get that. All right, now we get into text mining. And here's kind of the diagram of what text mining is. You're bringing in unstructured data, structured data, whether it be databases, specific knowledge bases that you want to push back out, and you're going to extract knowledge from all these different resources, put them together, and utilize that as your means to gain information from this data set. Again, back to get make knowledge out of the data, and then get information out of the data, and then knowledge from the information. That's what we're talking about here in the text mining process. These are the 3 main steps in text mining. You have established a corpus, which is basically to collect all relevant unstructured data, whether it be XML files, web pages, notes, video recordings, whatever it might be. That's the first thing you do when establish the corpus, is it's known. The second step right here is to create the term document matrix, and that's you decide, should all the terms be included? There's stop words like and the and but and things like that. You want to have synonyms, homonyms. You want to have word stemming so that you don't have to worry about the cases used. So that someone has past tense or present tense, that those things all end up meaning the same things. And how is the best way to represent that data? Should you show that in cells and those indexes? How do you do that? Are the row counts? Do you count how often something shows? Do you use logarithmic features to do those type of things to understand what's important? And then the final step is to extract the knowledge. This is the part of getting the knowledge out of the data which you've turned into information. You're going to use classification for categorization. You're also going to use clustering or natural groupings of the text together. And you're going to change how you improve the search recall, improve the search precision. And you're going to scatter all that together. You're going to have a specific clustering association methods you'll use. And from that, you're going to be able to get the data extracted out of your text mining process. And here's an example of how you create the term document for that. The term document matrix allows you to list all the documents you have in there, and then it will talk about what terms you're gleaning from each ones, and knowing whether the data is from a vendor, for example, that may have specific meanings on it, or whether it's from a better source like a government source or a non-prejudicial source, so to speak. Now we talk about sentiment analysis. It's the belief, the opinion, the conviction that people have. You're trying to answer the question what people's beliefs or their feelings about certain topics are. You're going to analyze how those related opinions may be using a variety of automated methods to do so. It's used in a variety of different domains. It works for CRM. It also works for any kind of things that to glean how the customers feel or whatever about you. One of the things you do is you have the sentiment detection. You retrieve the data and you prepare the text from it. It's also called detection of objectivity, or trying to figure out if the data is a fact versus an opinion. So a fact is objective. It's not no one's opinion. It's raining. Yes or no? Is it raining? Subjective. It's raining hard. What's hard mean? That's an opinion or whatever. So you have a fact versus a subjectivity. And then you want to make sure you want to have a polarity classification. Given a particular opinionated piece in the text, is the goal to classify the opinion falling under two major opposing things? Is it a negative or a positive? So you want to say that is more negative or more positive. And then finally, a target identification. The goal of that step is to accurately identify the target of the expressed sentiment, whether it's a person, a product, or an event. It's the level of difficulty times the size, the type, what the domain is, makes it difficult. And finally, a final step is to collect and aggregate. Once all the sentiments of the text data points are identified and calculated, they are to be aggregated and put together, put in a word statement, a paragraph, a document, something that speaks to what you're getting out of the sentiment analysis. You have several different applications. They'll call the voice of the customer, the voice of the market, the voice of the employee. Those are things that will come up. It will tell you based on what they're seeing, how either your customer, the overall market views you, how your own employees view you. It also works for brand management, letting know how strong is your brand. You know, Coke, very strong brand. Apple, an incredibly strong brand. And then also financial markets. What does the stock market think about? What do analysts think about you? And then today you also need to think about politics and government and all those type of things as well as part of sentiment analysis. Very important piece. There's a whole process in the sentiment analysis. You take the text and it lays it out right here. The textual analysis. Here you have a statement. You know, you want to calculate how the polarity, whether it's very positive, how much of it is swaying one side or the other, to help categorize how these things are done. The next thing we'll talk about is web mining, or a lot of people call it web data mining. It's as it says here, it's the process of discovering relationships about web data, the textual and the linkage, how those things all come together. It's the largest repository of data, whether it be HTML, XML, text format, pictures, whatever it may. Some of the challenges of processing the web data: the web is too big for effective data mining. It's just too complex to be able to do it. There's too many different paths you can go down. It's very dynamic. It's not specific to a particular domain. It's all over the place. It has everything, and opportunities and the challenges with it are extremely difficult to corral. Then we talk about web content and structure mining. You're monitoring the content, the text content of the web, the data collection via web crawlers. If you're not familiar with web crawlers, there are software pieces that go out there and look for things for searches, and they bring back, they're out there looking at different pages, trying to get things back. They include hyperlinks, authoritative pages, hubs. They call it hits, the hyperlink-induced topic searches, all those things. Those are things that the web content structure mining is trying to do as part of the data mining, text mining, and the web usage mining. And now when you're talking about web usage mining, it's the extraction of how the data is generated through the web pages and the visits. How do they serve it? Who is it? By cookies, by logs? What are the characteristics of the users that come in? What are their profiles? Are they all of a certain demographic? Are they all from a certain region, whatever it might be? You care about clickstream data, things that are coming through there. And then you want to do clickstream analysis, which tells you how people are navigating through your web pages to get understanding of how successful you are at driving the traffic where you want it to be. It also determines the lifetime value of the clients. Marketing strategy across products allows you to evaluate promotional campaigns, if they've been successful or not. You can target specific ads and coupons by larger groups to see if they're successful. You can predict if a behavior is based on a previously learned rules or set of profiles. And you want to present dynamic information to users based on their interest in their profile, so that you can learn from this, so that going forward you know exactly what it is that your customers, and you can try to lead them down a certain path to see the things you want them to see. The next big thing I want to talk about is search engines and how powerful they are and what they do. Why people use them. As you probably know, the big ones that most people are aware of: Google, Bing, Yahoo. But what is a search engine? It's the program that searches for the documents, comments, files, any kind of reference to what you put in there. They provide you information, then what they want to see, and you bring it back. They are basically the window to the internet. Without search engines, the internet would never have become as popular as they have. It would feed Alexa, would feed Siri. All these things are based on search engine technology and what they're used for. How does that happen? You have two things. You have the development side, which you have a web crawler and a document indexer. So it's going out there and it's constantly looking for data, and it's archiving, put into an index out there so that you can look at it and say, right there, just like you have the index in the back of a book that will tell you what page a certain subject is, it's exactly what a search engine does. And then it goes out there in a query, and it tells you which ones are most used, how the documents match, how high is a particular reference in content, how many times does it show up. That's basically what search engines do. It's the intention of the activity for the search engine to make as many sites visible as possible. That's the idea theoretically. And again, what you've seen is that they're huge in how profitable companies are. Google gets a ton of revenue. Facebook gets a ton of revenue from people paying them to have their stuff out there. But all that's based on when people go out there and create their content, they do it knowing how search engines work and how that data is going to bring things back. They purposely set their pages up to do a certain way so that they are get more hits on it. That's what they get paid to do, and bring back key items. That's why it's so important for people who are developing web pages to understand how their content is being consumed and what the web crawlers are bringing back, so they can stay on the top of the list. This is a little bit older, but it's an idea. You can see some things haven't changed. So you look at the top 15 most popular search engines, but this is back in 2016. You have Google, Bing, Yahoo, Ask, AOL. I was surprised. Wow, web crawler. Look at them all. DuckDuckGo, Dogpile, IXQuick. Those are some of the big ones back then. Now you take a look. This is from 2019. The top 3 haven't changed. Believe it or not, AOL is still a major player. Shocking to me. DuckDuckGo is up there, but look at this. You have Twitter and Wiki and Ask.com. And then you get into what I'll call the international ventures into it. Google obviously is worldwide, so is Yahoo and Bing, but now you have Baidu, which is specifically for China. CC Search is actually for the content. It's a content creator search. And then the final one is Yandex, that is for Russia. So what you're seeing now is specific sites being for certain geographic locations in certain countries, and they're changing the whole dynamic of the web engine, of the search engines out there. And here again, you kind of see just a flow of how it works. You go to the website, the pre-processing, and you extract knowledge, you get patterns, those type of things out that. And that's how you're doing the usage mining by using clickstream analysis to show how people click back and forth on your web pages. And you want to know how many people visit your site. You want to know where they come from. You want to know what their demographics are, how much they make if you can get that information, how much they surf on the web, how much money they spend on the web, and what was it to get somebody to come from Google to Bing? How do you do that? Or how do you get from Google to your website? How do you get them to come to your site versus the others you might competing with? All critical things you want to do in your web analytics metrics. Again, these are some of the things you care about: the page views, how long people stay on your site. Are they just passing through, or are they staying there to read? How much things do they download? What do they click? Where do they come from? Are they coming from other websites? Are you seeing it because they're coming from a travel site to your hotel site? Are you seeing it because they're coming from a trade magazine to your manufacturing place? Are you seeing it because they're coming from a chat room? Whatever it might be. These are all important things about how data and where data in the web analytics metrics play. And the final piece of this is the visitor profiles. What got them there? What brings new people there? How do you content those together so they do it? What part of the country are they from? What time of the day are they coming? All information you're capturing and trying to track to get your web analytics metrics that you want to capture, and then make decisions on, make changes in potentially how people come to your place. Here you have a sample dashboard that you would see that, and this comes right off of Google Analytics, by the way, that shows you all the different things in a dashboard. And this is a very good look at what a dashboard look at. So it's telling you what your traffic is. It tells you how many users you have per day in the last 30 days, how many sessions are by the day of the week, how long they last, what browsers brought them there, those type of things. So these are all, this is a great example of a great web analytics dashboard that you would go after. The final part of the chapter we talk about is social media analytics. You care in the social media, what's the reach? What's the industrial and social media technologies? What scale are they capable of? How they reach out to global audiences? You care about their frequency. How often do people come? How often is people visiting there? How much is it updated? Is it faster, cheaper than others? You want to know accessibility. This is the production of industrial media where typically government and corporate owns, and it's very costly, where social media tools are generally available to the public at little cost. You care about usability. You want to see how comfortable people are going there, what makes them come back often if it's good. How immediate is the data? Is it stale? Is it updated all the time? And then ultimately, you want to know how much updatability of it is. Do you want to see that things updated very often? Is it something like the weather, people going every day? These are things that you care about. And from there, you can glean a lot of the social media analytics out of a system. That covers it for chapter 6, or I'm sorry, for chapter 5. Next week, we take our next step, and that will be going into chapter 6, which is we're now going to get into prescriptive analytics. And we'll start talking about optimization, and more often we'll talk about simulation. And that will be the next kind of the final phase as we get nearer to the end of the chapter. I am still trying to get the Zoom thing set up. I had a problem with Zoom. They're getting slammed by everyone trying to do Zoom. So right now I can't get a guaranteed time slot. And until I can do that, I won't be able to have the Zoom sessions. Thanks, and hope everyone stays safe and healthy. And please reach out to your classmates if they're not listening, because they can't get the assignments if they aren't paying attention to this. Thanks.